So the topic about thermal properties of the metal. The last session we were discussing heat capacity and thermal capacity, heat capacity or thermal capacity or specific heat capacity. So you have to learn the formulas for both. First one for heat capacity. So heat capacity is equals to energy divided by the temperature change. Whereas specific heat capacity is equals to energy divided by mass into temperature change. Symbolic representation of the formula, how we represent the specific heat capacity and heat capacity. So symbolically we represent heat capacity by letter capital C is equals to energy. Energy, some books you will find they use letter Q, some books they use letter E, but I prefer to use E because it is easy to recognize that E energy is there. So I will use E here. But in the book, you may find that instead of E, they write Q. That's the same thing because in the book, most of you will find Q is also representing the energy. But I prefer to use E for energy so you will not make a mistake. Then the temperature change, how we represent the temperature change. Whenever something is a change, we use this symbol delta. This is called a delta. And because it's a temperature, so it will be capital T, means temperature change. So where C is the heat capacity, E is the energy, and delta T is the temp. Specific heat is also denoted by letter C, but it will be small letter. Energy, we will use E, or you can also use Q, divided by mass, which is M, divided by temperature change, that is delta T. So C is equals to EM delta E divided by M delta T, or capital C is equals to E divided by delta T. So what is the difference here? Capital C stands for heat capacity, whereas small c stands for and the small c is representing the specific heat capacity. So you have to learn these formulas as well as the definition. In exam, they ask to define heat capacity. So the standard definition of heat capacity is energy needed to produce temperature change by 1 degree. And if they ask define specific heat capacity, that's energy required to change the temperature by 1 degree for 1 kilogram object. Now some examples related to this. So in this question, a domestic hot water tank which contained 200 gram. So always try to sort out the values which are given to you. So 200 kilogram is the mass at 20. So that's a starting temperature T1. How much energy must be supplied to this water to heat this water to 70? So the final temperature is 70. The specific heat capacity of water is given. So specific heat. So it means small c is given. So the formula which relate the small c, the specific heat capacity is energy divided by mass into temperature change. The difference in the temperature, which will be, in this example, initial is 20, final is 70, so the temperature changes 50. So specific heat capacity is 4200. So we write 4200. Energy we don't know. M is the mass of object, which is 200 kilogram. And the temperature change starting from 20 and ending at 70. So change in temperature 70 minus 20, that's 50. So this whole is divided. this whole is divided because we need E, so it will be multiplied with the numerator other side, so it will be 4200 multiplied by 200 multiplied by 50. That will be the energy. So 4200 multiplied by 200 multiplied by 50. So the final answer is 42 million. So it is, whenever the number is too big, you can write in terms of the prefix, you can say it is 42 megajoules, because one megajoule is equals to this number. So we can convert this. If you write in exam, you write this as an answer, that is correct. Even you can use the power representing in a scientific notation, like you can write 42 into 10 to the power 6 joules. That is also the right way. Is it clear, this example, how we work out the energy required? Anyone having a doubt or a question on this part? Any question or a doubt? Then the state of the melting, before comparing the state of the melting, some questions related to the specific heat and thermal capacity. Like I have two objects. I supplied same amount of energy. For object A, I supply 1000 joule. For object B, I also supplied the same energy. They have the same mass as well. Like example, I was having 5 kilogram of object A and I'm having 5 kilogram of object B. But when we supply the energy, the temperature change for object A, it changes from 20 to 22. For object B, originally it was at 20, but its temperature changes to 30. Which object is having the higher specific heat capacity? We supplied the same amount of energy. We have the same masses as well, but the only difference is the temperature change. Temperature change for A, it is a small change in temperature, but for B, it is a greater change in temperature. Which object is having a greater thermal capacity? Yeah, that's, so when we work out, the correct answer is A. A is having a higher thermal capacity than B. You can work out from the formula directly. As you can see, the formula for specific heat capacity is energy divided by mass into temperature change. So we supply the same energy, we have the same masses. The only thing what is the difference is the temperature change. So the object which will have, because one side the quantity is in numerator, the other side it is denominator. So it means they have inverse relation. If one of the quantity increases, the other will decrease. So that's why the one which will have a smaller change in temperature will have a higher thermal capacity or specific heat capacity. You can also calculate this directly. There's a formula. If you want to calculate for A, if I want to calculate the specific heat, energy divided by mass into temperature change. So energy is 1000 joules. The mass of A is 5. and the temperature change is 2. So when I solve 1000 divided by 10, the specific heat, the value of the C, will come out as 100 joule per kilogram degree centigrade. But when we calculate for B, the thermal capacity is energy divided by mass into temperature change. So it is 1000 joules. The mass is 5, but the temperature change is 10 here. So when we solve 1000 divided by 50, so it will be 20 joules per kilogram degree centigrade. So you can clearly see that B is having a smaller specific heat capacity than A. So those objects which are having the smaller change in temperature, when we supply equal amount of energy and the object will show a smaller change in temperature, will have a greater thermal capacity. So without calculation, it can be done just using the formula, or if you want to calculate and work out, you can also use that. Is it clear? The concept of the thermal capacity or heat specific heat capacity? Then what happens in a process of a melting? When we supply heat energy to a substance in a solid state and it converts into a liquid without changing a temperature, we call that as melting. And melting point means temperature at which a solid is converting into a liquid. We call that as a melting point. Boiling means when we supply heat energy and the liquid convert into gas or vapor, but there is no change in temperature, we call that as a boiling, and the temperature at which this process occur, we call that as a boiling point. Condensation means when we remove the energy from the gaseous state, it converts into a liquid. We call that as condensation, or freezing or solidification. When a liquid is there, we remove the energy and it turns into a solid. We call that as solidification. So these are the names for the process given. If we have a solid, we supply heat energy, it turns into a liquid. If we supply heat energy, it will turn into a gas. But liquid turned into a gas can be boiling, can be evaporation. Already we discussed the difference between the boiling and evaporation. If it is only at the surface at any range of temperature, it is evaporation, but at a specific temperature, it will be boiling. And gas turned to liquid or liquid turned into a solid. So remove it getting colder. So gas turned to liquid, we call condensation, or liquid turned to solid, we call that as freezing. So when something gets hotter, it means the internal energy increases, and something get colder, the internal energy will decrease. The heating curve, like example, when a solid is heated for a longer period of a time, the solid first melt, then it will boil. This is refers to a heating curve. Like example, we have a substance originally in a solid state. So we supply energy, the solid temperature is increasing. So here the solid temperature is increasing. But once the solid start to melt, there will be no change in temperature. And if there is no change in temperature, a temperature at which a solid is converting into a liquid, what we call that temperature, we call that as a melting point. Then we have both mixture of a solid. Once all of the solid convert into a liquid, then the liquid temperature will rise. Once a liquid start to boil or liquid is turning into a gas, there is no change in temperature, and temperature at which a liquid turn into a gas, we call that as a boiling point. Is it clear? If we further supply heat energy, the gas temperature will increase, so the curve will point upward. So this is a heating curve, a curve which shows a change in temperature and change in state for an object originally in a solid state. Any doubt in the heating curve? Then a cooling curve is opposite. Like when we remove the energy, like originally we have a gas. Originally we have a gas. The gas cooled down, so temperature of a gas is decreasing. Once the gas turned into a liquid, that's condensation or a boiling point, same thing. And here we'll have both gas and liquid state. Then the liquid start to freeze. Then the liquid temperature is decreasing. Once the liquid start to freeze, what we call that as a freezing point. And all of the liquid, once all of the liquid turn into a solid, then further the solid temperature will decrease. So in a heating curve, we supply energy. In a cooling curve, we remove the energy. Then what is the meaning of latent heat? So basically, latent heat means energy required to change the state. The term latent heat means energy needed to change the state of an object. And specific latent heat means energy needed to change state of 1 kilogram object. Like example, I have an object in a solid state and its temperature example is 120. I am supplying heat energy. And what I observe when I'm supplying heat energy, the substance melt. It was originally in a solid state, but now it turned into a liquid state. What is the temperature of this liquid formed? What will be the temperature? Originally the solid is at 120, we supply the heat energy and we observe at 120 the solid start to melt. What is the temperature of the liquid formed? So whenever we change the state, there is no change in temperature. So if solid is at 120 and it is melting, the temperature of the liquid which is formed, that is also 120. Because whenever there is a change in state, there is no change in the temperature. So if we say I provide or I supply 2000 joules here to melt, so how much energy we need to melt the substance to change the state, that energy is called latent heat. So heat needed to change the state. Like example, I have a substance in a solid state. I'm supplying energy so the substance changes the state into a liquid. How much energy is supplied to a substance? That is simply refers to a latent heat. Another example of a latent heat, you have a container which is filled with liquid. So you have a container which is filled with a liquid and you're supplying heat energy. So you're supplying heat energy and you observe the liquid is turning into gas. So when a liquid turns into a gas at a specific temperature, we call this process as boiling. So if liquid was example at 100 degrees centigrade, what will be the temperature of the gas form? That is also 100 degree centigrade, because whenever there is a change in state, there is no change in the temperature. So the energy which we supply, like example, we supply 4000 joules to change liquid into gas. So how much energy is needed to change the state? This energy, what we call this energy is known as the latent heat. So latent heat is basically the energy needed to change the state of a substance. Is it clear, the concept of latent heat? Anyone having a doubt? But when we use the term specific latent heat, the term specific latent heat means energy needed to change the state of 1 kilogram substance, that is known as specific latent heat. Like example, I have say 5 kilogram ice. So I have 5 kilogram of ice, 5 kg of ice is there, and it is at 0 degree centigrade, and I supplied heat energy. I'm heating the ice, and I supplied 1000 joules to this ice. And what we observe, because it's a melting point of the ice is 0, so it start to melt, it will turn into liquid. So originally it was solid, but now the state is a liquid, that is also 5 kg. What is the temperature of the liquid form? That is same 0 degree, because the temperature does not change when the state changes. We call that as a melting. So what is specific latent heat? Specific latent heat means energy needed to melt 1 kilogram, to change 1 kilogram of a substance. So here 1000 joule is there for, so 1000 joule is for 5 kg. But I need specific latent heat. The term specific means I need energy for 1 kilogram. So it is energy divided by the mass. So 1000 divided by 5, what I will get? It will be 200 joule per kilogram. It means for each kilogram, to melt the 5 kilogram ice, I need 1000 joule. But if I want to melt 1 kilogram ice, I only need 200 joules of energy. So energy required to change the state of 1 kilogram substance, either from solid to liquid, liquid to gas, or opposite, that energy is known as specific latent heat. And the formula is energy divided by mass. Is it clear, the concept of latent heat and specific latent heat? Specific latent heat is for melting 1 kilogram, and latent heat is for total object. Like how much energy is needed to melt the whole object, we call latent heat. But how much energy is needed for 1 kilogram of that substance, we call that as specific latent heat. You have to learn these definitions for latent heat as well as specific. The formula for specific latent heat, so the specific latent heat, that is energy divided by mass. So how we represent the symbolic representation? Specific latent heat is denoted by letter L, energy can be E or Q, and mass is denoted by M. And what about the unit? Unit of energy is joule, and unit of mass is kilogram, so it is joules per kilogram. Is it clear? The concept of specific latent heat. So the formulas which you have to learn for this part, the three formulas as we already discussed. The first two, the heat capacity. The second one was specific heat capacity. And the third one is specific latent heat, which is energy divided by mass. So when we say latent heat of vaporization, the term vaporization means when liquid turn into a gas. So it's the same thing. When a liquid turn into a gas, we call vaporization. And so how much, and fusion means when a solid is turning into a liquid. So how much energy is needed to convert 1 kilogram liquid into gas? We call it specific latent heat of vaporization. And how much energy is needed to convert 1 kilogram of solid into a liquid? We call that as fusion. It's the same thing, only this word is added. If solid is changing into liquid, we call fusion. If liquid is turning into gas, we call vaporization. There is no difference in the two definition other than the change in the state. So example, in an experiment to find the latent heat of fusion, we want to find the latent heat of fusion. 15 kilogram metal is there, which need 520,000 joules of heat energy to change solid to liquid. We have to calculate latent heat of fusion. How to calculate latent heat? That is energy divided by mass. So energy is 520,000, whereas mass is 15. So 520,000 divided by 15. So we need 34. We need 34,000. So it is 520,000, the original value, divided by 15 is equal to 34,666. There should be 10 here, which is because the original value is 520,000. So what we have discussed today, I want everyone to learn these formulas because it is very important. Direct questions are there. Number one, the heat capacity, that is energy divided by temperature change. Number two, specific heat capacity, is equals to energy divided by mass into temperature change. And the specific latent heat is equals to energy divided by the mass. Symbolic representation for these equations, that also it's important. So heat capacity denoted by capital C, energy is E, and temperature change is delta T. Specific heat is small c, energy is E, M is a mass, and delta T. Latent heat is L, specific latent heat is energy is E divided by mass. And learn the unit of thermal capacity, joule per degree centigrade, or it can be joule per Kelvin depending on the temperature value. The unit for specific heat capacity, it is joule per kilogram degree centigrade, and the unit for latent heat, it is joule per kilogram. Is it clear? The three formulas. So these are very important formulas. You have to learn these. So there's no other formula in the thermal physics. You have to memorize. Only these three formulas are there. Uh, there was the gas law P1 V1 equal P2 V2. That was in topic 2.1. But topic 2.2, only these three formulas are important. So we'll continue this topic tomorrow, which is about the thermal properties of the matter. And we'll complete this 2.2 tomorrow and discuss the questions related to the topic.